need to filter out sensitive tools from client listings while keeping them available for internal use. You'll see how to implement a listing filter middleware that dynamically removes tools tagged as private from the results without modifying the underlying tool registry. The pattern uses FastMCP's middleware hooks to intercept and transform listing operations, ensuring clients only see what they're allowed to access.
From FastMCP server middleware, import middleware. Middleware context. Class listing filter middleware. Middleware. Async def on list tools. Self context. Middleware context, call next. Result equals await call next. Context. Hash filter out tools with private tag. Filtered tools equals. Tool for tool in result. If private, not in tool tags. Hash return modified list. Return filtered tools.
This demonstrates the interceptor pattern applied to tool discovery in FastMCP's middleware system. The pattern creates a transparent filtering layer that modifies the list of available tools before they reach the client, without altering the underlying tool implementations. What makes this distinctive is its non-invasive nature. You control visibility at the infrastructure level, not by modifying each tool individually. The interceptor works by wrapping the tool listing operation in a middleware hook that executes after the core server generates the full tool list. This creates a clean separation between tool registration, where tools define their capabilities, and tool exposure, where middleware determines what clients can see. The approach follows the chain of responsibility principle, allowing multiple middleware layers to progressively refine what gets exposed, with each layer focusing on a single concern like security, feature flagging, or client-specific customization. This pattern solves the common problem of managing tool visibility across different client types or permission levels without scattering conditional logic throughout your codebase. It's particularly valuable in multi-tenant systems, experimental feature rollouts, or when you need to maintain backward compatibility while deprecating tools. The trade-off is that middleware filtering happens at runtime rather than build time, so it's best suited for scenarios where tool availability might change dynamically based on context, rather than for completely static toolsets. Let's break it down line by line.
From FastMCP server middleware, import middleware. Middleware context.
Imports the base, middleware, class, and its context type from FastMCP's server middleware system. This establishes the foundation for creating custom request interceptors that can modify or filter tool listings before they reach the client.
Class listing filter middleware. Middleware.
This defines a middleware class that hooks into FastMCP's tool listing pipeline. Middleware pattern lets you intercept and modify requests or responses, here specifically filtering the tools list before it reaches the client.
Async def on list tools. Self context. Middleware context, call next.
This defines the middleware hook for tool listing events. The onListTools method intercepts every request to list available tools, allowing modification of the results before they reach the client. This is FastMCP's middleware pattern for filtering or transforming tool outputs.
Result equals await call next. Context.
This invokes the next middleware in the chain, passing the context forward. The await ensures proper async execution order, letting downstream middleware process the request before filtering. This is the standard middleware delegation pattern in FastMCP.
Hash filter out tools with private tag. Filtered tools equals.
This implements list comprehension to filter tools before returning them to the caller. The pattern efficiently processes collections in a single readable expression, replacing explicit loops. It's the Pythonic way to transform data while maintaining clean, declarative code.
Tool for tool and result.
This is a list comprehension iterating over each tool in the result collection. It processes the tools one by one, enabling the subsequent filter condition to evaluate each tool's tags. The pattern efficiently transforms collections while maintaining clean, readable code.
If private, not in tool tags.
This list comprehension filter eliminates tools tagged as private from the result set. It enforces access control by preventing internal tools from appearing in public listings, a common pattern for implementing visibility rules in tool registries. The check leverages Python's in operator against the tool's tags collection for efficient membership testing. This closes the list comprehension that filters tools by their tags. It completes the transformation from the original result set to a new list containing only non-private tools.
Hash return modified list. Return filtered tools.
This returns the filtered tool list, replacing the original response. Middleware pattern in action, each layer can transform the data before it reaches the client. FastMCP middleware pattern. Middleware intercepts and transforms both listing operations and execution flows, enabling consistent filtering across the entire component lifecycle. Filtering in on-list tools must align with access control in on-call tool to prevent metadata leaks through inconsistent visibility. The middleware chain executes sequentially, so order your middleware classes carefully for predictable behavior.
The middleware that sees everything controls nothing. Yet the middleware that controls nothing sees everything.